Alright. Okay, let's continue. Where am I again? Okay. If I remember correctly, I am in chapter 11. Currently in this one. Okay, let me check. Okay. We already got this one. Seems seems chat of chat. Wait, hold on a minute. Char pointer. Is this correct? Oh, okay. And this one, okay. Yep. I thought that this is alpha env instead of alpha. So yeah, my mistake. Okay. I think we need to free the sims. Free the sims too. I think. But yeah, do we need that? I mean to copy stuff. It's alpha. Right. Alpha. Okay. I mean, if alpha sim, right? Currently we are just putting the symbol as is without any memory allocation. That's because the memory address is still available until we delete the abstract syntax tree, which is Come on, where is it? So during the eval process, we should still have the symbol from the abstraction track 3. I think it is. I'm not sure if it is string literal or not. But yeah, the memory address still exists until we delete that. Okay. Next, we can create two functions that either get value from the environment or put values into it. To get a value from the environment, we look over all the items in the environment and check if the given symbol matches any of the start string. If we find a match, we can return a copy of the start value. If no match is found, we should return an error. We look over all the items in the environment and check if the given symbol matches any of the start string. The given symbol matches any of the start string. The function for putting new variable to the environment is a little bit more complex. No match is found, we should return an error. Okay, so first we create the get function to get the value from the environment. Return the copy, right? And if there is no match for the symbol, and we have to start set string no match, we should return an error. Okay. Function for putting new variable into a bit more complex. Yes. First, we want to check if a variable with the same name already exists. If this is the case, we should replace its value with the new one. To do this, we look over all the existing variables in the environment and check their value and check their name. Check if the variable name exists or not. If it exists, we should replace its value with a new one. Environment and check their name. If a match is found, we delete the value and store a new value, the input value. If no existing value is found, that name or the name doesn't exist, the variable name, we need to allocate some more space to put in it. put it in. This I can just look and store its name at the newly allocated location. Okay. Okay, let's get into this first. And we get if the symbol, for now we are not using any memory allocation, right? So I think we should be fine without freeing the symbol. But now let's see how it goes. But now let's try this one. Lenviget. Lenviget. Where is it? Struck. Oh, we written a file pointer. Okay. Get a file. Struck env struck. Value. It's quite long. So I break this. Maybe I should. And let's create what is it called, function declaration or prototype first for the put. Okay, we return nothing, right? Okay, we are using malloc, right? Okay, so okay. So what is it called? We kind of create the space to store Is it not the symbol in the space? Yeah, that's why there is this memory allocation. And let's create the, what is it called? The function prototype or function declaration first. Struct env value. Oh, I think this is, wait a minute, this is the old value. And this is the new one. Okay, maybe no. With no existing entry. Okay, non-existing entry. So if the variable does not exist yet, we allocate the space for the variable. I think that's what it means. Go on, right. Copy malloc string name. Okay, let's click that. No alpha get right. Struct env. Not that one. Okay. Trying to following the Linux kernel coding style. sign in. Plus. Return the copy of the variant. Wait a minute. Yeah, I think we need 3. If we need to create a space for the new symbol or variable name, I guess. What does it seem? Hi. Something like this. Okay. And then alpha copy. Okay, I already add a comment here. Which means that in case we need to allocate a specific memory, then yeah, we need to change this. Okay. The symbol is symbol might not be string literal. So okay, string GMP. The return value is integer, right? It's using unsigned character. Okay, so I think it means there's no negative value. Maybe indicating the result. Okay, 0 if it is equal, negative or positive if it is not equal. Okay, so with that in mind, right, I give this equal sign so that we didn't directly using the what is it called? Using the value from strcp or the strcmp or string compare directly. And to make things easier to understand, I guess. And then the value same. Equal 0. Now maybe something like this. But yeah, let's do this, I guess, in one line. Or we can do this. I'm not sure which one is easier to read. Let's leave it like this. And when we return the copy of it. Okay. Return. Hello, Inon. What is your age? Around 20. Well, in the mid 20 or late 20, I guess. That is a secret. Why do you want to ask my age? Is that relevant to the current study session? False. Okay. So we are looping this, right, until the count to check if the symbol exists or not. If it is exists, we return the copy from the environment. If the symbol exists or found, we return an error. Okay. If I remember correctly, we need this, right? So yeah, something like this. What is the error message? Symbol does not exist. And then of course the file name, right? And the line number. Okay. And one symbol. Yeah, let's use different error message for that. Okay, void alpha put, right? Right. No, not that one. And v out new. Well, let me copy this instead. And then unsign for I equals 0. Okay, we are putting the new variable or the new value inside the existing variable. If I understand correctly, iterate over all items in environment, right? How many variables we store in the environment with the count here. Wait, did we already define how many count we have or increment the count? Maybe in the letter content. Okay, we iterate this, right? And then we check if the symbol or the variable exists. If it is exists, we can delete the value, and then we are, what is it called? We are putting the new value by copying the new value. Okay, let's check that out. And I guess if there is nothing in the environment yet, which means the count is 0. Let me double check with the init. Right, I declare count as 0 when we initialize the environment. Okay, and then count plus okay. There is multiple line, so you need to use this compound statement, right? I mean, I'm trying to use my own implementation of string CMP, or well, maybe it is from the Stack Overflow, I guess. But yeah, I'm trying to use that instead of this strcmp. In the standard C library. Just to see how it goes. Env V seems right, and then we compare that to the new sim, right? Oh, we compare that to old. The old symbol. Interesting. I mean, yeah, I need to know how do we use this. Okay. What is the name of that Emacs bar at the bottom? I'm not using Emacs. I'm using Tmax and Vim currently. See, I'm using Tmax. So yeah, this is not Emacs but Tmax. And well, this is Vim. So yeah, there's that. Okay. Alright. No, not that one. Alt. Okay. Thank you. Okay. I mean, I'm still learning, I guess. And get confused quite a lot. Okay. Alright. RCLP. Okay, we delete this one. We copy the new value. Oh, I mean, do we really need the old value to, or maybe this is not the old value, but another value. Yeah, what does K in here mean? And what is V? A variable found, or the symbol found, right? This one, replace with variable supplied by user. And if this is the new value, right? Then maybe we should use V instead of K. Because again, we use this V, use V instead of K, right? Copy that value. Yeah, why is the symbol using K instead of V. That's kind of interesting. Hello Timo, welcome back. How is your journey going? And anything cool recently? I'm not sure if this is cool or not, but I'm trying out to create, what is it called? Something like relog array, this one, relog array function, which basically means that which basically mean something like what is it? Multiply overflow safety guard in relog, something like that. However, unlike relog array fails safely in the case where multiplication would overflow. So I'm trying to mimic that, I guess, with the help of this. Let me open this. This is from OpenBSD. Let me copy this in the chat. Do you know why relog returns void pointer? I'm still not sure why the relog return the void pointer. Or wait. Is it related to something like malloc? It accepts a pointer and resizes the memory it points to. Why can't it just resize the pointer you pass in? That is an interesting question. Yeah. Why does it have to return something? Can you assume the input was resized? Right. I'm still I haven't found the what is it called? I haven't found that answer yet. It may move that region of memory. Okay. So when relog move the region of the memory, is it always free the previous memory? Okay. P1, P2, if we relog P1, oh, is adding the region of memory, what is it called, always on the previous previous memory region? Let's say we have P1 and P2. Is it gonna append to P3 or maybe append to the before the P1 region? I'm still not sure about that. How resize the memory, right? Okay, I mean, at least I'm from the main page, right? If the p or the pointer provide is null, then the call is equivalent to malloc, something like that. And yeah, I'm still not quite sure how reloc works. Non-portable. Do you have recommendation, like the resource for learning? Step book. Let me check. Oh, this one. Is this the one? Okay. Let me copy this in the chat. Yeah, I haven't. Oh, wait, what about the license? I mean, I'm not sure if this is fine to show on live stream. Free space. Oh, this one. Okay. Wait. Let me check the license before showing this. There's number. Let's take a look. Oh, this is the PDF. Okay. Alright. So maybe I will take a look at this. But yeah, thank you for the suggestion, Timo. But for now, I think I want to get familiar with C first. Dynamic storage. Oh, okay. This is interesting. Let me copy this. Okay, this is a PDF. A survey and critical review. Let me check. Okay. Let me copy this in the chat. Learning C means you have to learn this stuff. You should understand how the function you're calling works. Exactly. I mean, that is why I'm kind of struggling to understand how this works, right? But yeah, I want to take step by step, one step at a time. And well, currently I'm trying to follow this book to get familiar with the C syntax and something like that, right? But yeah, thank you for the suggestion, Timo. I mean, again, I'm not sure where to start learning, right? So I just use this book and changing something from there, I guess. Okay. Paling tabel. Book electronic. Oh, okay. Convenient. Alright. Okay. Simple explanation. Dynamic storage allocation. Manage memory. Okay. Malloc and friends manage memory block. To track the memory block, they attach metadata to beginning or end of a block. For example, malloc 37 correspond to MD 30 bytes MD. Oh, and MD keeps track of information about the block and the next block. Okay. MD equal pull free struct MD next. Pull free MD data negative. Oh, the data and then data and the data and the data until the size provide, right? Okay. And then when we free, we are only removing the metadata, or some people call it label, I guess. But we are not actually cleaning the value inside those memory block, if I understand correctly. Maybe, what is it called? Maybe the analogy is like, and we also need to free, right? So that just makes the MD free equal 1. But it's very expensive to move stuff around. So what you can do is have a separate free list. A separate free list. Okay. So we had another list. Okay. Oh. malloc, we can look through the free list. Is that supposed to be free and then use? Okay, so if I understand correctly, we have this list, right? I'm not sure what it is called. Virtual memory list, maybe something like that. Oh, only keep track of the free block. So if the memory block is used, is it gonna be taken out from the free list? I mean, I'm trying to understand about the process. Okay, let me try. So if we have free, right? Let's say 69 bytes, and then another free 42 bytes, right? And then another free 69 42 bytes, and then when we use malloc 69, this free will disappear, something like this. You could keep them all in the linked list if you want to, but that's really slow. Oh, okay. And then when we free the, the 69 pointer, let's see. How do I the 69, let's say, the label, right? The heap appear again like this. Yeah, let's say VP. Right, okay. And then the memory block appear again. Oh, okay. And then malloc will fail if this free list is empty, right? And we put it back there, right? In this one, the 69 bytes. So then we need to allocate new heap memory. The system call for that is SPRK generally, right? I mean, I think I've taken a look at the map, but yeah, I'm still have no idea about this or SPRK. Right. I mean, currently I'm trying to familiarize myself with the C syntax, so I haven't going deep into this. Yeah, and map is fun when you understand it. You become a powerful programmer. that's my goal to become a powerful programmer, But again, I want to take things one step at a time, right? By understanding the syntax and the C syntax and stuff. But yeah, I will take a look at this, or maybe this book that you recommend. Well, maybe, but yeah, I'm trying to make things really clear, There is not that much to it. It's best to focus on operating system concept that will make you a agile programmer in the future. Okay, well, I'm currently curious, what is it called? Some people do embedded programming stuff, right? And from what I know, the embedding programming is kind of different from the operating system. From the programming in the operating system, right? So yeah, I'm kind of curious what is the difference when we doing embed. Let me type this. Embed programming and programming in operating system. I guess some people call that the embedded system doesn't have operating system or something like that. But it is basically the same stuff. How the CPU work and operating system is just CPU level programming and upwards. Oh, okay. Alright. Okay. Yeah, maybe I will take a look at the operating system after I finish this book. I want to finish what I start, right? So yeah, it might take a while. The book also explaining the string. That's quite late. It's good, there are a ton of rabbit holes in system. Yeah. That's the interesting part. What is it called? That's what make me interested, I guess, in the system programming. It's kind of interesting to look at, how does the memory works, how does the CPU works, something like that. But yeah, I want to take one step at a time. All of this resource can be overwhelming when we try to tackle everything. Okay. Thank you, Timo, for the explanation. Yeah, I had question about that stuff too, about an operating system and It took me how everything fits together. Right, that is interesting project. Did you, what is it? Did you write your operating system in, what is it, x86 or maybe ARM? I mean the architecture, Oh, x86. Okay. Right. I mean, I think there is some people suggesting to try learning with ARM. Oh, the 64-bit. Okay. Yeah, x86, 64, something like this, right? Yeah, I think some people recommend starting from ARM. If I remember, what is it called? ARM programming guide, something like this. Yeah, this one, ARM developer. Reject all. Maybe this one. Yeah, and I need to go back to check the reference. But less flexible. Oh. Okay. Simpler but less flexible. Okay, so I'm kind of curious. Is there any difference when you're building operating system 64-bit and 32-bit, I guess, other than the size, of course? Then after that, okay, you should learn about the hacker level stuff like malloc and whatnot. Then after that, you can dive into CPU stuff. Oh, okay. CPU stuff equal operating system. Okay. PCV. Oh, okay. This is interesting. x86 has different mode. 16-bit mode, real mode, 32-bit mode, protected mode, and 64-bit mode, long mode. Oh, okay. I learned something new today. Thank you, Timo. And Hunter says welcome. Oh, right. I've heard about RISC-V, but honestly, I'm still not sure about RISC-V. Is that how you pronounce it? They are more or less backward compatible, but 64-bit mode can unlock more than 4 GB of virtual address space, which make it a whole other level of programming. Right. Because if you have 32-bit address, 2 is 4 GB of address. Okay, right. In case anyone didn't realize, Programming became harder as the hardware become more capable, I guess. Some people, I think, say this. So the more, what is it called? The more capable the hardware, the programming, the programming problem become harder. That's why when we trying to program for 64-bit rather than 34-bit, we might find a whole new challenge, you could say. Okay, receive. Oh, Rix 5. Yeah, but it's not too bad. There are just some new features in 64-bit you have to worry about. But a lot of it is disabling other crappy features which make it easier. Honestly. Oh, okay. Okay. Yeah, I mean, it is an interesting challenge, I guess. And oh, okay. Yeah, I'm still not sure about this. Rix 5. Is Camel support this? Or maybe this is simpler than yeah, I'm not really sure. Let me put this in the chat. In case anyone wants to take a look. Oh, there is a fundamental course. Interesting. Let's take a look. In the Linux Foundation. Okay. Rix 5 is an ISA focusing on simple instruction. Complex instruction set. Complex instruction set. Reduce instruction set. We use it in embedded system. Oh. Wait. A lot of universities are moving to VC because it's easier. I guess. But I prefer x86. It's really nice. Oh, okay. I mean, we use this for embedded system. Do we need a specific, what is it called? A specific hardware for this? Okay, let me copy this in the chat in case anyone curious. I mean, like ARM, right? Where is the ARM? Well, this one, I guess. ARM have a specific hardware, right? Like some kind of the CPU. For embedded system, you just need to understand how the memory model works for your CPU, and they are more or less the same. Okay. We have MMIO for that, and some TMA and stuff too, but I don't think you need to worry about that. Okay, yeah, that's way advanced for my current knowledge. Okay, if we are starting with risk V, can we just use the virtual machine? The address bus has not only physical RAM, but also registers of device which are mapped to some place on there. Okay. It's not only physical RAM but also register of device. Is it, what is it called? The virtual memory? Is what you mean virtual memory, Timo? Or maybe other thing? I think, what is it called? She also have this register keyword, if I remember that correctly. I never used it before, but from my understanding it is something related to the CPU. Oh, virtual memory is different. Oh yeah, this is for general purpose on-chip CPU register. Hardware devices have their own register also that are not on chip. Oh, okay, so register just hint to the compiler. This value will be read aloud. You should save a register. It's not worried, maybe if you can. Oh, is it something like case? Is register like case? Because CPU registers are the fastest for accessing they are literally on the CPU's chip. RAM is far away. Oh, okay. Yeah, that's another software visible memory resource. Registers are the fastest. Cache are second fastest. RAM is slowest. Oh, so we have another cache mechanism. Okay, this is interesting. Second fastest, RAM is slowest. Okay. Alright. Cache third fastest. Cache second fastest. Wait. Yeah. I'm still not sure about the case in your example here. When you start your CPU or OS dev journey, you will get a chance to learn more in depth about it. Okay. So yeah, let's not jumping too far away, I guess. Okay, we will take step by step. But it is kind of interesting, Case on chip, but not as fast as register because they are larger. It's our storage at the end of the day. Okay. We are storing the value, I guess. Something like that. Okay. It's our storage at the end of the day. The difference is that how fast the storage is. Something like that. Okay. Picking them, then as human. But yeah, all of this stuff is covered in the AMD or Intel x86 manual. When you start OS dev, which I think you're hitting toward, yes, that's what I'm hitting toward. You will get a chance to read about it and see processor magic. Okay, processors are the most insane invention humans have ever created. By the way, it's freaking crazy. Oh, okay. Yeah, I mean, ever since I know about computer, I'm kind of curious what's happening underneath, right? So yeah, you could say that the CPU is kind of interesting invention that I want to learn. Let's put it that way. There are software invisible storage like internal CPU buffer, which are used to optimize loads or storage to memories. Okay. I mean, I've heard about, what is it called? TLD. Take a look. Buffer, I guess. Take a look. Buffer. In, what is it? CPU, maybe? Oh yeah, TLP. Case for virtual memory translation. Translation local set buffer. I mean, this is very new to me, so I'm still not really sure. It is a similar idea, but just to have the MMU, memory management unit, if I understand correctly. Okay. To have MMU. Okay. Yeah, this one memory management unit. Okay, so case. Right. So the TLP or MMU is different from the gates. that you're talking about? When you access a virtual address with a lot or store, it goes through the MMU first to get the physical address. On x86, you program this with bits table. Okay. Alright. I'm still okay. Now, gauge is a general principle. It depends on your architecture, how it works. But generally, there are instruction and data gates different to keep frequent stuff nearby. Okay. Do you have a Discord? I'm trying to create, what is it called? The Telegram channel, I guess. If you want to join too, or well, I can create. Okay, well, I will create a Telegram. A Discord server. Okay. Oh, you done this Telegram. Alright then. Maybe later on I will. Okay. See you next time, Timo. Okay, so take a look. Okay. Okay, let's continue this. Okay. We are currently in this. Wait, no, not. Okay, this one, right? We delete the value and then we copy from the environment. Oh, sorry. We copy the new value here. Into this one, the environment. And this is, I'm still not sure. Like, do we really need this one? Let me check first. LENV boot. Oh, okay. Okay, so we only store the symbol in K, and we store the function in V. Okay, interesting. So I think I misunderstood. So let's put this here and like this. No odd sim fun. He put okay. So we check the symbol, right? But yeah, calling it sim and then sim might sound weird. Like this, right? Sim and then sim. But that's what it is, even though we have another, what is it called? Another symbol, I guess. Yeah, that make me kind of curious. You know, like, do we need the whole thing, right? Do we need every value in this, or maybe we can just have the symbol, which is, if I remember correctly, right? This one. The same. Yeah, maybe we can change that to an env boot, right? Rather than giving the full, the full allocation, because we are only using the symbol value, right? Okay, where is it? In K, right? We have K here. We have also K here. K here. Okay. But we are only using the symbolic one. And if we take a look at the file sim, we are only assigning the symbolic one, okay. Or maybe jar name. Yeah, I'm thinking of changing this to char. So we only need to pass this one, the pointer char, rather than passing the whole struct, I guess. Char and then sim. I'm trying to do things differently. Is anyone curious? I didn't want to follow the book as is, if possible. And then NV files, I guess, and then we copy that. Fun. Okay. Copy. Oh, and then return, right? We immediately exit the function. Return. Okay. This kind of make me curious. Can we, or should we like remove this one and just using if? Right, not that one. Something like this. Let's find out. NV count plus unlock util. Okay. NV files. Size of NV files. Wait. That's not the unlock util. The pointer, right? We are reallocating this pointer or this memory segment, I guess, or memory block. And yeah, I think we should use what to put the files. Okay, struct alpha pointer to pointer, new unlock. Or maybe I can declare this new unlock and then we can reuse that. Unlock util, this is the memory block that we want to reallocate, right? And then the size. We want to reallocate in this one, pointer of pointer. Alright, let me check. Copy cell, okay. Cell, and then element, okay, crown. Right, and then the size. Which size should we use? Okay. Size of NV files. Of course, this one and then another one. Mine. If new unlock is no, and this should be env, okay. Should I change this to malloc? No, I mean unlock using relock underneath, so should be fine. And then if there is no problem, we assign that to the env files like this. Okay. Oh yeah. You unlock and then we re-unlock again this one, right? For the symbol. Unlock. Wait. Yeah, let me change this to same. Okay. Right, this should not be cell, but false in there and seams in here. Okay, now NV seams, right? If there is no error, with the allocation, we put this in here, and then we make this null. Okay, and then after that we are doing this. We copy the function or the value new. If we count negative 1, I mean, there might be some kind of overflow or wrapping if the count is 0, but yeah, we need to prevent the count becoming 0. Maybe wait a minute, and then we count. Right, let's say we have a new environment, right? And then the new environment at the start, and then the count should be 0. And because the count where is it? And because the count env, right, unsigned, if it is negative, then we might wrap to the maximum value of unsigned integer. Again, if you take a look at this, when we first start out, the count is 0. Putting new variable, right? I'm not sure how this works when we just recently create the environment. Is it gonna become negative? I mean, when we create or initialize the new environment, can't start from zero. Oh, right. I skipped this. I forgot, I guess. We already increment this. Right. So yeah, this should be fine. My bad. The mixture that gun is not zero. No, not this one. This is the mixer that when we add new value, the count represent the current value, that we can add that museum. Okay, so count never be zero when we are doing this, and then we copy that from we create malloc. Okay, maybe we need that. We count malloc string length sim plus 1. Right. I mean, I think I can check. Where is it again? Not in init, but is it? Oh, I think this one. When we are trying to copy. Okay. String length plus 1. Maybe we need to try handling the integer for flow, I guess. From the what is it called? Addition operation. And then we copy to the seams. Okay. Seams. We count. Seam. Variable evaluation. Okay, I guess that's it for now. We will continue this on the next session. Okay, thank you for watching and see you next time. Bye bye.